Welcome to the future of manufacturing excellence, where precision meets innovation. openZDM, an initiative that aims to revolutionize the world of cyber-physical manufacturing. openZDM paves the way for a new era of sustainable manufacturing, targeting zero defects through proactive quality control and reconfiguration. With a mission to develop and demonstrate a cutting-edge open platform across 5 diverse production lines, we are on a relentless quest to make perfection the new standard. Join us on a journey of transformation as we unlock the potential of interconnected technologies, harnessing the power of data, and fostering collaboration like never before. openZDM is a joint effort with 18 partner organizations spanning 7 European countries, all committed to a single mission: realizing zero defects in cyber-physical manufacturing. But why is this project so crucial? The manufacturing industry faces immense sustainability challenges. It grapples with defects, inefficiencies, and environmental concerns. These challenges have prompted the openZDM project to set its objectives high. In fact, at openZDM, we believe that perfection is achievable and every product can be flawless. openZDM aims to transform the industry by proactively identifying quality issues, online reconfiguring processes to prevent them, and thus reducing waste and making manufacturing greener and more efficient. So how do we plan to achieve these ambitious goals? It all starts with the openZDM platform. The openZDM platform is a state-of-the-art digital ecosystem that integrates cutting-edge technologies such as visible VIS range, infrared IR range, laser line triangulation systems, and X-ray diffraction. It's designed to provide manufacturers with real-time insights, predictive maintenance, and a holistic view of their production processes. With the innovative openZDM platform, manufacturers can monitor their entire production chain, detect defects before they occur, and make data-driven decisions. But don't just take our word for it. openZDM is putting its innovations to the test with 5 real-life manufacturing conditions. 2 energy-intensive production processes are included: glass bottles and steel suspension arms. 1 process oriented to electrification, production of batteries, and 1 process consuming renewable materials, wood-based panels. 1 process consuming renewable materials, and 1 in vehicle assembly. Let's take a closer look at these groundbreaking demonstrators. Led by Sonae Arauco, one of the main worldwide players of wood-based panels, our first pilot, Decorative Surface Panels Manufacturing Demonstrator, aims to achieve a 25% reduction in defects, increase throughput by 10%, and decrease production costs by 10%. This leads to the improvement of product quality, a significant decrease in waste, and better decision-making. Vidrala, one of the main glass container manufacturers in Western Europe, is leading our second pilot, Bottle Manufacturing Demonstrator, which targets a 25% decrease in defects, as well 30% decrease in raw material and energy consumption. The expected impact of this demonstrator include reduction of defective products, early detection of problems, and improvement on the quality levels. As a key strategic partner in the Portuguese automotive industry, Volkswagen Auto Europa is leading the vehicle body shop and final assembly demonstrator. The main goal for the demonstrator is to detect non-compliant products earlier in the production line and therefore reduce the number of products that need further alignment. In this way, third openZDM pilot would save 20% of time needed to verify the product and decrease production costs by 15%. VDL Veveler, a leading international designer and manufacturer of air suspension solutions for trailers, trucks, and buses, is at the forefront of our fourth pilot. Trailing arm production process demonstrator aims at 50% defects reduction and up to 10% decrease in production costs. The approach used in this demonstrator will adjust the production process to deviations or abnormal patterns, ensuring the production of high-quality products while enabling a zero-defect manufacturing process. Last but not least, behind openZDM pilot number 5, EV battery production demonstrator, is Aptiv, a global technology company that develops safer, greener, and more connected solutions which enable the future of mobility. The main objective of this demonstrator is to minimize the number of defects that are generated during the production of the battery trays and enhance the reconfigurability of the process. In this way, Aptiv's pilot could achieve defect reduction by 50%, increase throughput by 5%, and decrease production costs by 10%. The future of manufacturing is here, and it's openZDM. We invite the entire manufacturing community to join us on this exciting journey. Engage with openZDM through social media, visit our website, and stay connected to witness the transformation of the industry. Together, we're shaping a sustainable, defect-free future for European manufacturing. Visit openzdm.eu and join the manufacturing revolution.
Welcome to Line 11. This line was commissioned in 2020 and is the world's first Industry 4.0 glass manufacturing line. On the way down, we stopped briefly at the feeder platform, where we saw the glass being cut into individual pieces called gobs. The gobs are then loaded into the blank side of the machine where the basic shape of the bottle, a parison, is formed at around 1200 degrees. The parison is then inverted to the blow side of the machine where the final shape of the bottle is made. The bottle is then transferred onto the machine conveyor where it heads off for annealing. At this point, the temperature is 700 degrees centigrade. The machine you're seeing here is an M-Hart 12-section quad gob machine, which means each section of the glass-making machine can make 4 bottles at a time at very high speed.
Volkswagen Auto Europa is a Volkswagen Group plant in Portugal that is currently producing the Volkswagen T-Roc model. Volkswagen is dedicated to find innovative solutions and embracing cutting-edge technologies. It has engaged ambitious R&D projects with the goal of improve efficiency and sustainability while maintaining the high standards in the automotive industry. In the context of the openZDM project, the pilot at Volkswagen Auto Europa aims to improve the manufacturing process by identifying potential defects and trends in real time to prevent their propagation to downstream processes. Ultimately, this will support production networks' zero-defect processes. The pilot is focused on the alignment operations, which are mainly based on the measurement and control of gaps and flushes in parts of the vehicle. The quality characteristic of the geometric position of all assembled parts is essential to meet the quality standards of the vehicle. To this end, in body shop and final assembly, gap and flush checks are carried out on the 100% of the production to confirm the fit and alignment between two surfaces. Currently, gaps and flushes are measured automatically in the body shop and manually at the end of the assembly line by operators using manual calipers and feeler gauges that do not allow for data storage and therefore for correlation of data among different stages of the production. The available commercial manual vision-based sensors to measure gaps and flushes have not been successfully used in
This station's job is the core of the whole battery pack production, which allows us to laser weld our modules in order to be packed inside a battery and provide current and voltage transmission among all the cells. Once the cells are placed on the modules, 2D cameras will take an initial picture to check if something is wrong or may cause a defect. During the laser welding process, real-time thermo cameras are used to check the in-progress weld status. If something goes wrong, the cameras will notify to the platform the process results. During the exit phase, welds are checked again by 2D cameras to verify if there's a weld that aesthetically is defected or not. In case the operator needs to give a feedback about the result of the welding process, a feedback tool is provided for each picture that has been captured.